All right, Crouton Bones House of Math. You should watch the video that came before this, even though it's kind of messed up because I didn't have my blocking and framing correct. Of course, that's the one that records all the way through. All the other ones that I did. Anyway, oh well. All right, so the basic concept. We're going to be completing the square using 5 basic concepts. All we're going to do is count because mathematics is the study of numbers. We're going to make stuff equal. This is going to be a square equal to a square. Instead of just playing what's under the cup, it's going to be squares because we form rectangles to facilitate counting. 0 and 1, that's all we're going to do. So we have to know something about square numbers. We have to know something about substitution. We have to know something about making squares. All right, so let's knock out a whole bunch of problems, one after another. You get your blocks. You must get your blocks. Do not just watch this with your arms folded, or you will get basically no benefit. So what you want to do is get your blocks out. So get your blocks out, and you will enjoy ever so much better and understand ever so much better that what we really are doing is see, because like I said, the average person doesn't see that's a square, doesn't see that's a square. And then I'll do the substitutions and so on, but you are going to get out blocks. And it's the same problem that we just did to start with. What's our first problem? Our first problem is, well, actually, I'll show you all the ones we're going to do. You can write them down, or you can scroll down, or you could go over to the super duper super secret math group, and I put the PDF there that has all these problems on it. But if you wanted to, here, I'll hold it like that. Screenshot, and then I'll hold it like, I don't know, that. Screenshot, and then I'll hold it like that. Screenshot, if you need to. All right, so the first one we're going to do is x squared plus 2x minus 5 is the same thing as 3. Let's write this up here, shall we? X squared plus 2x minus 5 is the same thing as 3. All right. So what do we have to do? We got to get our blocks out. I'm going to draw pictures this time because you can see playing with Play-Doh and blocks takes way too long. But if you're on your kitchen table or on the floor, which is where you should be, knocking these out is no problem. So here's what I'm going to do. I'm going to see, what's the first thing I always do when I'm playing What's Under the Cup? I got to get rid of that because I have Hero Zero over here, and Hero Zero is going to be, oh, let's make it the right color. The same thing as, oops, we'll make this -5, and we'll make this 5. Well, let's see here. What's same? Well, you can't miss it. The -5 and the -5. So what do we wind up with? We wind up with 3 plus 5, which is the same thing, look at me being all fancy, as 8. Just combine, right? 3 and 5. All right, you're playing with your blocks. Right, you've got your blocks out. X squared 2x, and you had a -5, which means that you had one of these with your x squared and 2x. And then you got rid of that with Hero Zero, and the way you got rid of that with Hero Zero, see, I did symbols. Now you see blocks. Oh, look, there's Hero Zero. And you can see the stuff that's same. This one and the other one were same over there. All right, so now, let's draw this real quick. And what I have there is going to be, this rectangle is now an x squared and 2x, and over here I'm going to have 8. And I know where I'm going, so I'm going to do this. 1, 2, 3, 4, 5, 6, 7, 8. Let's move that one over just a little bit. Oh, look, it's even going to kind of sort of look like a square. All right. But you could have a 3 and a 5, and then later on just trade them in. All right, and then what? I didn't finish over here. I'm supposed to have 2x. So I have one like this and one like this. And see, even when I'm doing the drawing, that doesn't look so square. But if you have your blocks, you can't miss it that that's a square. All right, what's going to complete the square? Oh, I'm going to have to add 1, just like before. I'm going to have to add 1, just like before. Why? Because it's an equal sign. I can't just put 1 over here. Many students do this. So I'm going to add 1. So what do we have? We already know the answer. Right? It's going to be plus or minus. All right. Let's do it, though. In case you didn't see the other videos. All right, so what do I have? I'm going to rewrite this. I'm just going to say that what I have here... Oh, wait. We know something about this over here, so I'm going to have to make this the same as we just did before. Oh. And then what? You know what to do? Because I don't want to know about both. I just want to know about the one side. I want equal side. So if I square root u and I square root u, well, once again, Mrs. Fragglesnarts will have a hard time. The whole reason why we did this is so that we could make that x plus 1 squared. See, it's x plus 1. See, it's x plus 1. It's x plus 1 this way. It's x plus 1 that way. It's x plus 1 squared is the same thing as 9. I'm just rewriting this. And then I'm going to put this... look, I square rooted that. And I square rooted that. Oops, you can't even tell I square rooted that. Because I'm so close. Okay. Let's just put the whole thing in there. All right. There you are. Okay, what am I doing? I'm describing this right here, the one side. But when I put the square root sign on, now I'm just going to have x plus 1 equals 3. And we know the answer is, that means that x must be, oops, that's going to be plus or minus 3. That means x is 2 answers. It's either -4 or 2. How did I do that? With my friend Hero Zero. Yay, Zero. My hero, Zero, such a funny little hero. Well, till you came along, I counted on my fingers and toes. Well, actually, I got hose. But anyway. No singing. All right, so let's evaluate. So if I evaluate, but I'm not going to evaluate using blocks. I'm going to evaluate using symbols. Let's see here. 4, because that's what that says. That says that 2 times 2 is 4. Plus 2 times 2 is, so 4 plus 4 plus 1 is sure enough the same thing as 9. Or I could do the other one, my favorite, my more fun one. -4 times -4 is positive 16 minus 8. Because 2 times -4 is -8, right? Plus the -8 plus 1 is 9. Well, look at that. So we just evaluated. Oh wait, let me make it cooler. What's this? 4 times 4. What's this? 2 times -4. What's this? The one that was already there that we had. And what's this? 9. The square is equal to the square. 9 is equal to 9. That was problem number 1. What was problem number 1? X squared plus 2x minus 5 equals 3. Now we just converted it right back to x squared plus 2x plus 1 is the same thing as 9. But the problem we started with was x squared plus 2x minus 5 was the same thing as 3. And we figured out that x had to be the same thing as plus or minus 3. Oh, wait. X plus 1 had to be the same thing as plus or minus 3. So then x had to be... All right, there you go. Now everybody's happy. And here, I'll leave them. Oh, wait. Here, just for fun. Screenshotability. There we go. Perhaps later I'll take a screenshot. All right, let's do another one. Let's go faster. We're going too slow here, kids. We got to go faster. All right. And what are we going to have? For these, we're going to have 9 equals 9. So what am I going to have? We're going to have x squared 2x minus 15 is 9 now. Oh, this looks scary. Let's see here. X squared plus 2x minus 15 equals 9. Uh-oh. Well, when we play What's Under the Cup, is Hero Zero lurking over here? Why, yes. Hero Zero is, in fact, lurking over there. He's our hero. And what does he do? He says 15. Wow, this pen is already drying out and it's brand spanking new. That's better. All right. 15 minus 15. Okay, well, if I take away the same, yeah, there you go. The minus 15, the minus 15. Uh-oh. Now I have 15 plus 9, 24. And then what completes the square? 1. And what do I have? I got to add 1 over here, too. Can I just add 1 over there? Right? You got your blocks. Oh, so now what? Now I've got that same x squared 2x and 1 is equal to 25. Oh, look. It's this now. There's cat hair. That's funny. Oh, dear. Okay, now it's this one instead. It's not the pink one. It's this one. Have we built pyramids like this? Well, yes, we have. Do we know that this one is 25? Yes. All right. So a square equal to a square again. So now what it's saying is that this square must be 25. Well, can I do that yet another time? Let's see here. What am I going to do? I'm going to square root this. And then I'm going to square root this. And I'm going to figure out that that's the same thing as x plus 1 again is the same thing as 25. Was that hard? Oh, wait. Should I draw the picture? Like I said, you better be playing with your blocks. Better not just be sitting there like a fuddy-duddy. Not playing with your blocks. All right. That's way too rectangular if you ask me. All right. I want it to be square looking. That's why graph paper always good. And then they can see for sure it's a square. All right. And then I got to complete my square with that 1 again, like I did, right? And when I put the 1 over here, it made this, and I'm not even going to draw it all out. You can put 25. Boom. I had 24 and I added 1, 25. What did I do? I completed the square with that 1. Because I had 24 before. So I had 5, 5, 5, 5, and a 4, and a 1. So here, wait, I'll do it just for fun, just because it's fun. It's pleasurable. All right, what? Boggles. You guys always try to make this so hard, and I'm just playing around. You don't understand how many children I've had in my house crying because of algebra. Can you see what's going to complete the square? What completes that square? Oh. Can I do it? I need many fingers. Oh, look, I completed the square with 1. Okay, so now can I see what it must be? Well, my x square. There, look, there's my x square. See it? There's my x and there's my x. And there's my 1 completing it. You can start to see these even. And you could draw them on your graph paper. And I can see that, let's see here. Oops. It's not 25. By the time I get from square root down here, then it's going to be plus or minus 5, the one side of that rectangle. Because positive 5 and negative 5, when I square them, you get 25, which is the same as 24 plus 1. Okay, and then I can figure out my solution set. Well, what's x got to be then? Well, if I have it, then x must be, well, if it's going to be, right, it's going to be 4, as you could clearly see. 16, 4, and 4. Because I could build it. What? I'm just building the rectangle multiple ways. And then, what's the other one? Well, then it's got to be negative 6. Huh. Let's see if negative 6 works. because 5 minus 1 more. All right, so my answers are x is 4. I don't know how to put a comma and make Mr. Strikemiter crazy. Because -6 should go over there, in his opinion. All right. Actually, I tend to agree. Because on the number line, where is 6? It's over there. And where's 4? Over there. So they should be swapped. I won't argue. It's minutia, but it's important. Okay, so what? 4 times 4, you already saw, was 16. And then I had 8 more, which gave me 24. And then I added 1, and then that made the same thing as 25. And then I could do -6, and I'm going to get 36. Oh, look, I'm practicing my math. 36 plus 2 -6s would be -12. Or why don't I just put -12 there? And then I'm going to add 1 to that. And hopefully that's 25. Yep, because 36 minus 12 is 24, plus 1 is 25. Oh, look, I did it again. Don't tell me this stuff is hard. I'm so tired of people trying to tell me that this stuff's hard. Of course it's hard. When you teach it and they throw you in the deep end of the pool and none of them work out right and you got to do plus or minus the square root of some crazy number. Like I did when I was in my textbook for the first time. I need to bring those textbooks. Like whoever wrote those textbooks, man. Anyway, they weren't there to educate you. You just thought they were. All right, just making my squares cool because we got more to go. Oh, well, I didn't finish. I didn't finish, and it was 25 was the same thing as 25. Child's play. All right, what was my next problem? My next problem was x squared 2x minus 15 equals 9. I already know what that one's going to be, but let's do it. X squared. Oh wait, I think I just did that. I'm getting confused. What did I just do? I just did x squared 2x minus 6. You know what? Screw it. I don't want to do any more 2x ones. Let's do some 4x ones. Let's do x squared, because it's just going to be the same thing every time. X squared 4x plus 5 is the same thing as 17. Let's see here. X squared plus 4x plus 5 is the same thing as 17. I got to turn this into a square, and I got to turn this into a square. How am I going to do that? Well, I'm going to complete the square. All right, so hero zeros over here again. So what? I'm just going to subtract 5 from both sides. I'm going to take the shortcut. And what do I get? Oh, now I have 12 over here. Actually, I should leave this as the parent function. I'll leave that like that. And then I'll do my math over here. So here is x squared plus 4x plus something is going to be the same thing as I just took the 5 away. So that's going to be 12 over here because I know 17 minus 5 is 12. Oh, gee, what's going to complete the square? Get your blocks out. And let's see here. If there's 2 of them here and 2 of them there, what's going to go there? Well, look, they're all. I know you guys get all crazy. Yeah, are those still X's? All right. What about the pink one? What's going to fit right there? Oh, 4. Can you see that 4 is going to fit right there? No problem. I complete my square with 4. Oh, look, I completed my square. Because completing the square means complete the square. All right. So I complete my square with 4. Well, can I just add 4 over here? Let's draw it. Let's draw it. Oh, let's draw it. Okay. And then let's get rid of that. I don't know what it's going to be. And then let's see here. I'm going to put 4 of them in there to make my square. And see, my picture doesn't look square because I didn't draw it and I'm not being meticulous. All right. And then what's supposed to be over here? Well, if I add 4 over here, because see, I was like this, and I had, what did I have over here? I only had 12. But if I add 4 more, oh, suddenly I get 16. Oh, is 16 square? Well, yes, it is. So this is square. Because why? Because I added 4 over here, so I gotta add 4 over here. So now I have x squared plus 4x plus 4 is the same thing as 16. Ah. Do I get my friend the square root sign out again? Yes, absolutely I do, because that's what we do every single time. Somewhere right around here, I've had numerous students, boys and girls, mostly girls, start to cry. And why do they cry? Because, damn it, it's this easy. Had it happen numerous times. All right, so what's this? Well, then this is x plus 2. Now it's x plus 2. X plus 2. You can see it. X plus 2. X plus 2. The square. Every side of that square is x plus 2. And this over here isn't 16. It's 4. Because it's just one side. 16. If I have my 16, you should be able to see 16. It'll look like this is going to be a yellow one. And let's turn them all the right way. And what do I have? Yeah, it's that. So that must be 2 again. Right? Because 2 plus 2 is 4. Uh-oh! What I leave off? Plus or minus. Every time. See, when you do it over and over again, then it's like they don't forget. Because, oh yeah. But if you only did 1 or 2 problems. Okay, so what's it got to be? Well, then it's got to be, if it's, I'm going to have to subtract 2 over here, right? Because I take 2 from here and 2 from here. So it's going to either be 2 or negative 6 again. Because negative 4 minus negative 2 more is going to be negative 6. Was that going to work? Let's check if I got it right or not. Because I have all these students that tell me, I don't know if I got it right or not. How am I supposed to know? Well, let's see here. Let's put it in there and find out if your square equals to a square or not. And it does, as it turns out. Because certainly when I put in, you can see it right there, that 4 plus 8 is 12, plus 5 is 17. And then if I do it again, negative, so what am I going to have? I'm going to have 36, right? Because negative 6 times negative. And then I have 4, times negative 6 is going to be 24, plus negative 24, or just that negative sign. And then that's going to be the same thing as what number? Can you do the math? 12. And then what? And then I'm going to have to add 5. And sure enough, that's going to be 17. Let's do it over here. 36 minus 24 plus 5 is 17. Done. Okay, I must have got it right. Because this and this are equal. Like I said, it made me crazy. That's why my students get 100, because they know they got them right. If they didn't get it right, they go back and do it until they get it right. And they know how to get it right. All right, that's a 4x one. I don't feel like doing 20 of them, because it's going to be the same thing over and over again. I lied. I'm totally not doing 20 of them. All right, so... But let's do another one of these with 4x, because it's going to be the same thing over and over again. And if you wanted to, start off building an x squared plus 4x, and complete the square with the 4, and make that the same thing as, I don't know, 25 or 36 or 49 or whatever. And then you can go back to making fancy ones like this, where I have x squared plus 4x minus 8 equals 37. Let's find out if I can do that. Let's see here. What did I say? X squared plus 4x minus the 8 is going to be the same thing as 37. All right, get your blocks out. It's going to be the same one every time. Let's draw it real quick over here. Let's see here. Boom. There's my x squared. Almost went off the board there. And then what? I'm going to have 2 of these guys. And then what? I'm going to complete the square right there. See, and it's not the same when I do direct camera, because if I had a student, the dynamic and everything would be quite different. Let's use this for fun. Equals. Now we're going to have to figure it out. But okay, I got that far. Okay, but see, I had negative 8 and negative 8, so I'm ahead of myself. What do I have to do? Well, I have to do my hero 0 one more time. Is it ever different? It's never different. 0 and 1. That's it. That's all there is. Okay, so, what can happen? Let's see here. I'm going to have to add 8 to both sides, right? Plus 8, 0, 0, plus 8. All right, let's not do it over there. Let's write it again. And say that what I have here now is x squared plus 4x. And now I'm to that point where I have got nothing over here. And that's going to be the same thing as 37 plus 8. I think that's 45. Oh, what square number is that going to be? Oops, I got ahead of myself, see? So then I add my 4. And then I add my 4. And then I am going to have 49 over here. Just because I'm lazy, I'm not going to rewrite everything again. I'm just going to put 49. So you guys should be writing it down. And do all the steps and do each step at a time. And see, what they teach you in school is memorize the steps. What I'm showing you is, yeah, now you know why the steps. And then what? I got to square root again. Oh, look, it's going to be 7. So this is going to be 49, and this is going to be 49. So I just got to make sure that this equals 49. Well, how does that equal 49? Well, I square root both sides and figure it out. And I'm going to wind up with x plus 2 again, because I had x plus 2 squared. And then I had 49 over here. Like I'm doing the intermediate steps so you don't get lost. Okay. Actually, that's for Mrs. Stragglesnarts, so she can figure out what's going on here, because they're not very bright, you know. All right, so then, oh, did I forget again? Plus or minus. All right, so what's my two answers going to be? How about, let's do it in this blue just because. X is going to be the same thing as two answers. You know, and just for Mr. Strike Matter, I will do the other one. What am I going to have? I'm going to have negative 9 comes first. And then I'm going to have 5. Let's find out if that works. Oh, and this is supposed to be 49 over here. All right. So let's see here. Gee, that seems like a lot of work. Negative 9, shall we do that one first? Negative 9 squared is 81. And then I got to take minus 4 9s, which I happen to know is 36, because I can do multiplication in my head quickly and easily. And can you see where if you can't do multiplication, that's going to be a stumbling block as you're doing this, as you're a teenager and you don't know what 4 9s is? You're already confused and can't see any pictures, and they're only showing you symbols. And okay, so then you stare, then you square root, then you do that. Okay. So get the multiplication tables down. And then I got to take another way, 8 more away. I sure hope that's works out to 37. Let's find out, shall we? Let's see here. Well, should I combine these two or those ones? I don't know. Let's do 81. We'll leave that. Minus, 36, and then negative 8 more. That's going to be minus 44. And 81 minus 44. Let's do it this way. Let's see here. Well, I'm going to add 6 and get 7. And there's 1 less there, and that'll be 3. Oh, what do you know? It does work out. That is 37. Okay. Well, we got to do the other one. What's 5 times 5? 25. What's 4 times 5? Let's do it. 25 plus 20 minus 8. And sure enough, is 37. Right? 45 minus 8 is 37. How do we figure it out? By making a square equal to a square. This is not a hard problem. This is an easy problem. This is not anything difficult whatsoever. It looks all oh my goodness, but how easy is that? We're going to make a rectangle and a rectangle. Shall we do some more? Let's do another one. I don't want to play with 4x anymore. Let's do 6x. I don't know. Pick one of the 6x problems. Oh, I'll pick a super easy one. Let's do it like mega easy. Everybody, let's get it. Oh. Leave my 5 concepts intact. We're completing the square with ones that work, so that later on we can do ones that don't work. X squared is supposedly, because they all work. With algebra, we can always complete the square. Even if we figure out that, whoa, that answer is imaginary, we can still do it. Anyway, x squared, 6x, and 7 is 14. All right, let's do it. X squared plus 6x now, and 7 is the same thing as 14. All right. All right, you guys better get your blocks out. All right, boom. Got that. And then what? Got this. Oops, there's a clump of dried clay down there. All right. Oh. Retarded 10-year-old. What completes the square? Retarded 20-year-old with autism that was given to you by tiny hat demons who injected you numerous times. What completes the square? Yeah, I think they can see what completes the square. You can see what completes the square. Any little child can complete the square. Blind children can complete the square. And adults. And I've done it. Has to be 9 that's going to fit in there. Okay. What am I going to do? Well, I don't like this guy over here. So what again? Hero 0. And I'm just going to be quick about it. So I'm going to rewrite this. Look, now I'm flying. See, can I fly? Yes, I can fly. But first you take baby steps. And this could be over a couple of weeks. And you do it over and over again, and pretty soon they're ready for the next thing. And everybody's mastered it. And that's going to be 7. Oh, oops. There's no plus 7 there. It's 0. Look, hero 0. All right, what do I have to add? I already showed you. I have to add 9 to complete the square. I have to add 9 to complete the square. Oh, look, 16 equals 16. Right, so what's my 2 rectangles? My squares, I mean. Not just any rectangles, they're squares. Is 16 equals 16. Why? Because the equal sign never lies. So then what? Do I have to square root? Yes, because we're facilitating the counting using rectangles, and not any rectangle, a square. So I'm going to... Actually, you know what? Because you can't. If you skip a step, everybody gets confused. Because math is so hard. It's hard. Ask any liberal white woman if math is hard or not. She'll tell you how hard it is. And that you shouldn't tell them the math is easy. Because it's not easy, it's hard. Because of the methodology that we use. That's stupid and backwards. Okay, so let's... You should have patience for these people that harm children. I have no patience for people that harm children. None. Not any. They're not going to heaven. They will have millstones tied around their necks. Well, actually, that would be better than what's going to happen to some of them. Spoken from the mouth. All right. Of the Jesus. Not some toady. Not some internet fool. Not some social media maven. But the Lord Jesus Christ himself told you better to have a millstone tied around your neck and cast off a boat than what's going to happen to you if you have caused one of my little ones to stumble. You guys think we're playing around? We're not playing around. You guys been getting away with it? You've been getting away with it, but you're not going to keep getting away with it. Oh, wait, oh, what I did, I've been a mistake over here. Okay. Okay. What I do, just count to one side. And now what? Hero 0 again! I gotta use Hero 0 again. Look, he comes to your rescue over and over again. So now, X is going to be the same thing. Oh, don't skip out any steps, otherwise math will be hard! Alright, minus 3. Oh, there's my 0. It's a little egg-shaped. Let's see here. So if I minus the 3, then that's going to be a minus 7. Let's move you down. Actually, let's move you over. Let's just go over here and say X then is going to be the same thing as negative 7 and, ooh, 1. Because plus 4 minus 3 is 1. All right, let's see if that's correct. 1. Will that work? Well, why? And yes, indeedy, do it will. Because 1 squared is 1, and 6 more 1s is 7, and 7 plus 7 is 14. Oh, let's try negative 7. Negative 7. Uh-oh. Uh-oh. What's 7 times 7 again? How many steps up to 7th heaven? As one mom said when the child was trying to remember. Anyway, why? Because Lucky 7 Samson. Or whatever multiplication song. But anyway, 7 times 7 is hard if you don't know that it's 49. But if you've been playing with rectangles and building pyramids, you remember that the beige one, the one that's made out of these, is 49. Okay, so 49. Then what? Then 6 times 7 is 42. Oh my goodness. Well, no, it's not, because it's negative 42. Neener. Why? Because it's negative 7 6 times. And then what? And then I'm going to add 7, because this, get you out of the way. Come back to the original. So then when I add the 7, it gets to be 14. White is hot. Oh yeah, that's right. It's not hard. Somebody just lied to you and told you it was hard, and you believe them because they never showed you any pictures. Because see, just now I just did it. No pictures. But if you're playing along with your blocks, no issue. And then eventually you can get to see that, yeah, that's a square. And that's a square. And the square we're going for is 16 and 16. Because we're going to come back to x squared 6x plus 9 every time. And then there's going to be a time when we use difference of 2 squares instead. And there, well, let's go to another one. Oh, and you know what else? Bruh, you know what, you didn't show all that. You made it all hard and stuff, because I believe the liberal white women that tell you that math is hard and you got to just do all the steps. Well, why don't you just add 2? You could just add 2. Just add 2. Okay, let's do that. What if I just added 2 and then I added 2 and then I had x squared plus 6x plus 9 was the same thing as 16? Oh. And then I get my 2 right answers. Look, I'm already there. And if you can see it in your head, if you can see this picture, look how monochromatic it. And then what? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Oh. Get some of these. Oh. 1, 2, 3, 4. There you go. And what? These two are the same. That's it. Look, oh, symbols. Oh, look, drawing. Poured raw. All right. What? All I did was add 2. Why you gotta make it hard? Oh, because it's hard, because math is so hard. Well, it is if you can't see it. I'll have to agree that it can be a little hard sometimes. Shall I do another? I think I shall. Chauncey, can you draw up another problem for us? Yes, we can. How about x squared plus 6x plus 5 is 45. You know, I could subtract 5 from both sides and then complete the square, but you know what, you goofies. You know what I'm going to do? And you could add 4. You could just add 4. How about you add 4? Why would I do a silly thing like that? Well, because if I add 4 and I add 4, I wind up with x squared plus 6x plus 9 is the same thing as 49. Oh, look, a square equal to a square. You should be able to solve from there. Are these getting to be too easy? I think they're going to be too easy. Let's make a harder one then. You want an easy one or a hard one? Let's do a hard one. All right, let's stay with 6x. Oh, I like this one. Let's do this one. I like this problem. I actually like it. Me and this problem are friends. Okay. Let's see here. See, me and this math, we have history. It's been 36 years. But anyway, I like this problem because this is one of the problems where one of my students went, ah! And I didn't catch it on film or camera or anything. Oh well. Anyway, x squared 6x minus 7 is the same thing as 0. Well, look, hero 0 is already sitting there. So I say hero 0 is the same thing as, well, let's make it two colors. Negative 7, clearly. And how about green? Green is a friendly color. Since I already wrote it in green. All right, take away the stuff that's the same. Take away the stuff that's the same. Bro, you guys better be playing with blacks. All right, then what? Then I got to add 9 to complete the square. And then I got to add 9. Oh, let's start with the original problem again. What was it? It was x squared plus 6x minus 7 was the same thing as nothing. All right, so now that's where we're at. Okay, so now what? O is, that looked like something else, a different symbol. Let's see here. And then what? I got to square root both sides? Can I square root both sides? Look, I'm lazy. I'm not even going to do the math in between. All right, and then I'm just going to have x plus 3 is the same thing as 16, which means that x must be the same thing. Is there a hero 0 over here? 3 minus 3? Why, yes, it's the same thing every time. Oh, don't make me do another one. Okay, so then what? So then I'm going to have minus 3 minus 3. Right? Oh, what? This is supposed to be 4 over here because I already did the square root step. Okay, so then what? So then this got to be, x is going to be the same. Oh, wait, and it was plus or minus? Did I forget the plus or minus? I did not forget the plus or minus. Okay, so what then? X is going to be the same thing as 4 minus negative 7. And then, and 1. Did we already do that? Do I have to evaluate again? Or did you already see this? Do you want to see it again? I don't want to show it to you again because I'm not going to. And these are, like I said, these are the ones that come out perfectly. They're later on, we're going to do quadratics and all kind of stuff where they don't come out nicely, and you're going to have plus or minus the square root and so on. Oh, and then we can also do the ones, did we do all the even ones? Yeah, 2, 4, 6. Now let's do 8. Did we do 3, 5, or 7? No, because we don't know how to, or maybe we do, but we haven't done it yet. Square numbers that end in 5. But once we can do that, then we can knock a few of those out. And if you scroll down on this very page, you can see me doing a problem like that, where it works out to be like 12.25. And I forgot that the square root of 12.25 was 3.5. Anyway, let's do another one. 8. Oh, let's do one that it looks scary. Oh, it looks scary because math is hard. Oh. Already the x squared is scaring people off. And there's a bunch of people that will not watch these videos. All right, let's see here. Oh, let's do that. Plus 8x. And then minus 19. Oh, yeah, there you go. And then is the same thing as 29. Look at those 9s and stuff. Oh, and it's got a big number 19 there. And oh, it's all got it. But we will tame him with algebra. Okay, what am I going to do? I'm going to make a square equal to a square. And oh, wait, let me just show you this ahead of time. You better get your blocks out. If you don't have your blocks out, a pox on you if you don't have your blocks out. Oh, I don't have blocks. We'll get some. Oh, let's put it over here. And then what? Oh, I need one more. All right. Oh, fine. I need one more. There you go. So what's going to complete that square? I think it's going to be 16. Okay. So let's do the next step. X squared plus 8x. And then what? I got a hero 0 over here, so I'm just going to add 19. Oh, let's do it over here. is going to be the same thing as 29 plus 19. Why? Because 0, 0 is y. What's that going to be? Is that going to be... Well, yes, it is. Okay, so then I'm going to do the next thing. X squared plus 8x is... what am I going to do? Okay, and then boom. And then what? Well, I got to add these two guys together, which means that that's going to be like, what is that going to be? I don't know. It's really hard. There's 9s and there's 1s and everything. So that's like, I don't know. Is it like 30 plus 18 or something? And 30 plus 18? What's 30 plus 18? Why? Why? Because 10 plus 18. Oh, and okay, so 48. All right, now what completes the square? 16? And then what? Square root both sides. What's 48 and 16? This is like a whole bunch of 8s over here. There's like 6 8s and 2 more 8s. That would be 8 8s, and 8 8s is 64. But wait, I don't know that because I'm just a little kid and I can't do any of that stuff, right? I wouldn't know that 48 is a bunch of 8s and that's 2 8s. I wouldn't, because, I've never played and built stuff with these guys before. So that would escape me totally. I'm just totally just pulling stuff out. Anyway, but 64. Oh, is that a square number? Why, yes, it is. This is the brown square number. And then let's see, this one over here, I'm going to just have... Now can I square root? I don't know. Why would I square root? Why? Because I want a rectangle equal to a rectangle. Okay, so I make this one over here like this, and I make this one over here like this. And now I see that this over here is going to be 8, and this over here is just going to be x plus 4. It's what's under the cup again, and like I said, any little child can tell you, oh, that he left off the plus or minus again. And so now hero 0's over here, 4 minus 4. So what's my two answers going to be? Well, x is going to have to be the same thing as plus 8 minus 4, which is 4, and then negative 8 minus 4, which is negative 12. Yay, we get to play with 12 for a minute. Does it work? Let's find out. 4 times 4 is 16. Put up here. I'm evaluating. You should be believing blocks. It's 16, because you can see it totally when you play with blocks, as you saw just a minute ago. Okay, and then what? 4. That's going to be what? 32? Because, which one am I doing? 4 times 8? Yes, 32. And then minus 19, it should be the same thing as 29. I don't know if it is or not. Let's see. 48 minus 19 turns out to be 29. Okay, wait, we got to do the negative 12. Wow, it's a big number. Oh, still going to be 29. $144, because it's negative 12. And then 8 more 12s that are negative is going to be, or 12 negative 8s, depending on how you want your diction and grammar. Let's see here. I believe that's going to be something like 96. And then I got a minus 19. I think that's right. In fact, I'm sure that's right. But let's do it just in case. Where shall I put it? I shall put it over here. Okay, so what I'm going to do, I got 144, and I'm going to take away, because a lot of you guys can't do it this way in your head. You gotta line it up like this. And let's just do 96 and 19. Okay, this is 96, and then it's more 96. It's 19 more 96. We're going to go negative and negative some more. And, you know what I could do? Because it's 19, I'm just going to do 20. And that's going to give me 116, right? Because I add 20. Right, just make this into an 11. Oh, but it's 19, so I got to take away 1, which would make it... What would that do? Okay, Can you, right? See, and I go like this because I know it makes you crazy, and because hopefully you're fast enough. But if you're a little one, it actually takes you time to figure it out, even though I just told you the answer. But anyway, that's going to be 115. And sure enough, get 9. There's only going to be 13 there, and when I take 11 from 13, that's going to be 29. Yes, 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 it works, of course. And if it didn't, then we did something wrong, and you go back and check your problem. But see, my students get 100% because, did you get it right or not? Okay, now these all work out easily, and I know you're thinking, well, what about the ones that are plus or minus the square root of some queer number? Okay, yeah, we're going to do those much later on, not today. But now we have the concept down. We've done it over and over and over again. Same thing, different numbers, same concept. Rectangle equal rectangle. Shall we get crazy and do another one? I don't know. Let's do. Actually, let's make that its own video where I do something like these guys down here. Because any one of these. In fact, I could probably do these 4 on one video, and then you could watch that. But you should be able to knock those out yourself with your blocks. No issue. Now, it's going to be the same thing, except for the thing that I don't want to play with 2x squared. So what I got to do? Divide everybody by 2. I don't play with 4x. Well, I could, but I don't want to. But I could build this, and I think you could see how you could complete the square. And anyway, if you build these, they might be easier. And you can fool around with just doing symbols. You could draw pictures. You can do whatever you want, but these should be easy. You're exercising. Now, when we go to the next step, where maybe I don't know what the next step's going to be for all of you, but for me, the next thing I would do is start adding in the odd ones, 3x and 5x and 7x, and show how to do those. And make sure they work out nicely, and you have to do a little thinking because you're going to have decimals, but it should still be quite easy. And then you're going to have ones that don't work out at all. And then you're going to wind up with numbers like, oh, it's going to be, this is going to be a strange number, like, like say this is just for fun, just pulling numbers out of my butt. Let's say this turned out to be the square root of 13 or something, and then it was like x plus 5 was the same as the square root of 13. We don't know the square root of 13. So what we're going to say, that x is this, we can kind of sort of know, but I know it's between 3 and 4, but I don't know exactly. All right, so let's see here. It's going to be the same thing as negative 5 plus or minus the square root of whatever the square root of 13 is. Now this makes sense, because that's what that is. Okay, but evaluating the expression when it's a complicated answer like this is a little more work. But if you have a calculator, and everybody does, you can figure out what the square root of 13 is, and then put it in. If this was your answer, for example, is what I'm saying. But the idea is that we can do all of them. These all work out perfectly, of course, and then we get to the point where they don't work out perfectly, and you have complex numbers like we just did. Okay. I believe we'll quit there. Crouton Ramon's houseofmath.com for more. And maybe this evening I'll knock out yet one more set of problems. Just those 4 that have more than 1x squared. Right? See? Baby steps, baby steps, baby steps. Degree of difficulty. Right? We go up slowly. We don't just throw them in the deep end of the pool and all of a sudden they have to do problems that don't work out at all. No, you don't have an obvious square and an obvious square. You just do rules and process and wind up with crazy numbers. But with Mortensen Math, understand the concepts, and then suddenly, they get hundreds. All right, so check out allegedly advanced algebra. That would be the advanced algebra tab at Crouton Ramon's House of Math.